All right, this is 1.6 special quadrilaterals. We just finished talking about polygons, so you want to keep all that information about polygons and carry it over to this section. Now we just want to focus, though, on the special quadrilateral. So quadrilaterals that's got special properties. So the first one that I want to talk about is the trapezoid. So the trapezoid is a quadrilateral with exactly one pair of parallel sides. So when you see these two examples of quadrilaterals, they are not quite a trapezoid yet until you see proof. Remember, I've been talking about having proof on every picture. So because it looks like it, you have to see the parallel symbols, okay? Because in the definition, it has exactly one pair. Okay, over here, you have this one that are they have to have the marks in order to be parallel. Okay, so that's a trapezoid. I know you've heard of it before in your past since elementary school, but now we're going to be real discreet with showing that there's a pair of parallel sides. The next one, there's a kite. Okay, the kite is a quadrilateral with two distinct pairs of consecutive congruent sides. So that's the important part. Two distinct pairs. Consecutive, there's that word consecutive we talked about before. It means right next to, kind of like adjacent, congruent sides. So it's not, this is what a kite looks like, but it's not definitely a kite until you see these two marked congruent and these two marked congruent. Okay, so that is a kite. And then, yeah, that's it, that's the kite. The next special quadrilateral is the parallelogram. This is a quadrilateral with two pairs of parallel sides. So two pairs. So these look like they're parallelograms, but they're not until you see the symbols that they are parallel. Okay, so there's examples that you have to put the arrows on there. Over here, you have to have the symbols of parallel. So this is the little arrows that signify when lines are parallel. Okay. So I know you've seen that one before, but you got to make sure you see the markings. The next special quadrilateral is the rhombus. The rhombus is an equilateral parallelogram. So we had talked about what equilateral means. That means all four sides are equal. So you have to see the tick marks that look like this. Now, the unique thing about this is, we do have symbols to be parallel, but when you mark all four sides congruent, that forces opposite sides to be parallel. So these are the only markings that you need. Of course, when you have a rhombus, all four sides are equal, and technically you can show these symbols as well, but they're not needed, they're not required, because this rhombus number 1 over here has enough markings, okay? Rhombus number 2 over here is still correct, but you don't need all of those parallel symbols, okay? So a rhombus is an equilateral parallelogram. Next one is the rectangle. Y'all are most familiar with probably. This one's a parallelogram, okay? So it does have opposite sides parallel. And the special thing about this parallelogram is that it has 4 right angles, okay? And so we're going to put right angles in all 4, but I'm going to show you a couple of examples where the minimum requirement of markings is needed, okay? So you could do that. That forces it to be a quadrilateral, okay? When you have 4 right angles, it forces opposite sides to be congruent, okay? Sorry, I forgot to mention that over here on the on the parallelogram. When you have opposite sides parallel, it forces the opposite sides to be congruent, okay? So just kind of like the rectangle. So those end up being congruent. if you have opposite sides parallel. So same thing with this one. That one is congruent to that one. So you just need one or the other markings. Okay, so for instance, if I had a parallelogram over here and you see opposite sides congruent, but you don't see the parallel symbols, this is still a parallelogram. Okay, even though it doesn't show opposite sides parallel. If the opposite sides are congruent, it forces the sides to be parallel. Okay, so you don't need both markings, you just need one. Let me go back to the rectangle. And so you have 4 right angles, and so it forces opposite sides to be congruent. So let me draw another rectangle in which it doesn't have quite all of those markings, but it can still be represented as a parallelogram. So let's say it has opposite sides parallel, and it just shows one right angle. That is still a rectangle because when you just put one right angle and you know opposite sides are parallel, it forces all the other angles to be right angles. Okay. Another example could be this one. If you have opposite sides congruent, okay, if you have opposite sides congruent, but no right angles, then we're not sure it's a rectangle yet until you see at least one right angle. Okay, so there's some examples of rectangles with a minimum amount of markings, but all 3 of these still show enough proof to be a rectangle. Okay, in this middle one, you don't have to include the parallel symbols because remember, opposite sides prove that they end up being parallel. Okay, so I think that's the minimum that I have, but you gotta for sure show at least that one right angle. So I'm gonna put a little star next to that right there. Okay. All right, so that's the rectangle. It's a parallelogram with 4 right angles. And you could say equal angular also. So using that vocabulary word from our last section, polygons, equal angular, because all 4 angles are equal. Okay, the last one that we want to talk about is the square. This one's the most special of them all. Okay? Because it has all the properties of all the other figures. Okay, so it's an equilateral rectangle, so it has all the properties of a rectangle. It's an equal angular rhombus, so it has all the properties of the rhombus. And it's a regular quadrilateral. Okay, so remember, regular means equal angular and equilateral. So don't forget that one. We went over that in the last section. So first thing that you want to mark is all 4 sides being congruent. Okay, that right there, if you see a picture like this is not a square yet. This could possibly be a rhombus. So in order to turn it into a square, you have to show at least one right angle. So that's the minimum that is required, okay? But if you want to be on the safe side on what to mark, because you're going to have to sketch these, and you're going to have to show proof it is what it is. So back in elementary and in middle school, if you saw this shape right here, everybody said, yes, that's a square. And now that you're in high school, it's not a square until you show proof. So you got to at least mark all 4 sides equal, and you have to show that at least one angle is a right angle. Okay, why do you only need to show one? Because when all 4 sides are congruent and you have at least one right angle, it forces all of the angles to be 90 degrees. Okay, that's just the proof. Okay, when we start constructing, you'll see how that makes sense. Okay, so that's a rectangle. Maybe one other way to mark it, if I have a square drawn and you have all 4 right angles, don't assume that that's a square, okay? Because this could be a rectangle. The top and the bottom sides, like this one and this one down here, that could be slightly longer than this side and this side, okay? So you have to still put all 4 sides being congruent, But over here, this one, square number 3, that's the minimum number of markings that you need. Okay, so I just kind of wanted to touch up on that. What's the minimum markings that you need? Okay, so let's do some problem examples. Okay, so it says sketch and label the figure correctly, and it says that it's going to be rectangle ABCD with diagonals BD and AC intersecting at E. Okay, so we definitely want to draw a rectangle that looks like a rectangle. Okay, so there's my rectangle. It says that it needs to be rectangle ABCD, so I'm going to start A here. I could put B over here or B over here. It doesn't matter which direction you go. Okay, so I'm going to put it over there. Okay, and then C has to go in consecutive order based on our notes from our polygon unit or section. Okay, what I did a lot of, which is going to be incorrect because this is how we read books, a lot of kids will name it A, B, C, D. See how you read from left to right? So that would be incorrect. So let me mark it correctly. So A, B, C, D. And it has diagonals BD to AC. So I just need to connect those two. So I'm going to connect B to D, A to C. And then it says they have to intersect at E. So you want to label that point E. Okay, and that's it. You're done, right? No, you're not. Even though it looks like a rectangle, you still have not marked the important parts of a rectangle. So I'm going to flip back real quick to this one. Remember all these markings. Remember, we have to show proof. So we have to have all these markings on the rectangle in order to be known as a rectangle. Okay, so I have to do either a picture like number 1, rectangle number 1 over here, or rectangle number 2, or rectangle number 3. All of those are good examples. Okay, so let me go back to my problem example. So I want to, just to be on the safe side, guys, if you're referring to a rectangle, it might be best just to put all 4 right angles. Okay, you can put all 4 right angles, and technically you can actually stop right there. So if I had a picture like that, that's those 4 right angles force opposite sides to be congruent and opposite sides to be parallel. So you're done. That's one example. Now, a lot of kids will just do extra markings, and that's fine too. So if you have A, B, C, and D, and then you have your 2 diagonals, and that's going to be point E. And then you want to also include that opposite sides are congruent. And you said, well, I'm just going to mark 1 right angle. That's a good answer as well. Both of these pictures are good examples to have enough proof stating that this is indeed a rectangle. Okay, so just depends. If you're not sure what's the minimum number of markings to put, then just make sure that you put more than enough. Okay, it's better to have more than not enough. Okay, over here, based on the marks for each figure, what type of special quadrilateral can you assume each one to be? Figures are not drawn to scale, and perhaps we should redraw to scale, and that can be a strategy to help us figure it out. Okay, so right here on this one on the left, we have 2 right angles, and so I bet many of y'all are going to write that this must be a rectangle. Okay, but that is wrong. Okay, it's not a rectangle. So we're going to move this up over here. It looks like a rectangle, but it's not. The only thing that we have is that these are 4 right angles. So if you think about it, it doesn't say how big the sides are. There's no tick mark saying that this side is congruent to this one and that one's congruent to that one. So if you don't have those marks, then you don't know that they are congruent. So here's something to consider. So let's say we have, let's kind of draw the same shape like that. Because you know that these are right angles, and so you guys know what right angles look like. Now, we don't know the opposite sides are congruent, so what if this bottom side is slightly longer? So what we want to do for our own sake is maybe draw it extra longer, and then maybe something like that. Okay, so we showed proof and stuck to what was marked, meaning that one and those 2, but we extended that bottom side to be a little bit longer so we can see what other shape this could possibly look like. So in this case right here, when you have a right angle and a right angle, doesn't it look like these are forced to be parallel? And that is correct. So those are parallel. Nothing else is parallel, and we don't know that these opposite sides are congruent. Actually, no sides could be congruent, okay? So for this picture right here, this one is going to be a trapezoid because it has one pair of parallel sides, which it ends up being those two right there, okay? Okay, let's look at this next one. Everybody's probably thinking, oh, this is a square. It is not a square. Okay, the reason it's not a square is because it doesn't show all four sides being congruent. It does have a right angle, that is true. All it says is opposite sides are parallel, and then you have that one right angle, which forces all of these to end up being right angles. And it does look like a square, but we don't know that maybe it doesn't have these markings here. This side is congruent to this side, and that one's congruent to that one. So since you don't have those markings, I'm going to erase those. So for all we know, this bottom side could be maybe slightly longer. So you could have maybe something like this, where you still have that right angle, you still have opposite sides being parallel, and perhaps maybe the top and the bottom sides are slightly longer than the left and the right side. Okay, and so they do end up being. So what's the only other figure that has four right angles and opposite sides parallel? So this one here is indeed the rectangle. Okay, so I'm going to give you some examples like this on your homework that you're going to have to maybe redraw or utilize the shape, the markings, the parallel markings, the tick marks, and the right angles to see what kind of figure it truly is. Okay, and I always think maybe redrawing them another way might help. Okay, all right, last one. It says ABCD is congruent to LMNO. It says give the coordinates of the missing points. So obviously this looks like a special quadrilateral on the coordinate grid. And so it looks like, so this goes up 2 over 2. This one goes down 2 over 2. So that means that this side is congruent to this side. Okay? So when you have that same horizontal and vertical distance, that forces those. Same thing over here for the other sides, BC and BC. So it goes 1, 2, 3, 4, 5 over, 2 down. Same thing there, 1, 2, 3, 4, 5 over, and then up 2. So that forces these two to be congruent. And so now since AB, I want to focus on AB being congruent to LM, because that's what's marked whenever you see this statement right here. Okay, so LM is congruent to that. Now, think about it. From LM, we need to figure out where N would be next. So N is where C would be. So N corresponds to C. So L to M, and then C could be somewhere up here. Okay, so it goes 5 up and 2 down, so I can count that over here. 1, 2, 3, 4, 5. 1, 2 over. Okay, 1, 2, 3, 4, 5, 1, 2. So I could put C right there. And so I can mark from there to there. So that's the longer one. And then I can carry that same pattern over from L to get O. 1, 2 over, 1, 2 up. So that can be O. And then continue this one over here. So that forces those to be equal. So there's an example right there of where C, I'm sorry, not C. Why did I mark that C? N and O can be. So it looks like N could be at 3, 4, and O can be at 1, -1. Okay, now there is some more answers, okay, because we can go off the graph over here. So it could be something maybe like that, okay? But of course we have to draw it precise. So think of the kite where it can still go off the graph. That's not a big deal. So I'm going to go over 5 down 2, just kind of like I did last time. So 1, 2, so 8, 9, 10. So 1, 2, 3, 4, 5, down 2. So about right there. So that could be in right there. Maybe use a different color. Right. And then to get the other one, go down to 1, 2, over 2, because that's the way the pattern is over here, down 2, over 2. And that can be O. And so that's congruent to that. Is 1 tick mark. This one over here is congruent to that because it went over 5. And then you just need to connect these. And so there's 2 possible answers. So not only could you have that group right there, you can have n be at 8, 9, 10. That ended up being 10 right there. 10, comma, negative 3. Oops, I forgot to put a negative on that other one. Sorry about that, guys, because we went down. No, sorry. That is not a negative 3. I was right the first time. So let me get rid of that negative. That one was good, 3, 4. 10, negative 3. And then O is at 5, negative 5. Okay, so you have 2 possible answers, and so you need to make sure you list those possible answers, all of them, whenever you're answering these. Okay, and that's it.